So we're just going to learn about this?
Yes. So now, again, I know all of those questions seem very random, but they will make sense in just a second after we go through all of these. So essentially, all of those questions are demonstrating one of these heuristics or biases that I'm going to talk about. All right, so that is what we're talking about today, are heuristics and biases. So first, let's give you just a couple definitions. So heuristics are mental shortcuts that our brains use whenever we're trying to make a decision very quickly. So our brains tend to be very lazy. We like to take just like the shortest route to an answer possible, especially if we're pressed for time or we don't have enough resources. And so these heuristics, like I said, they're just these little mental shortcuts that we do to figure things out. Biases happen, so heuristics and biases go hand in hand. Biases often happen whenever these heuristics lead us to make like predictable systematic errors. So it's when we're making errors in like one particular direction. So let's write down those definitions real quick because I don't have them anywhere else in the slide, so might as well start with that. Okay, so we're talking about heuristics and biases. So a heuristic is just a mental shortcut. So a heuristic is a mental shortcut. A bias is a systematic error that leads to predictable mistakes. So bias is systematic error that leads to predictable mistakes. So that's what we're going to be talking about today. Okay, so some of the things you will see, so these heuristics, we use them because oftentimes they are actually very helpful. They can help us solve problems more quickly and more efficiently. But like I said, they also can lead to biases and errors in thinking. Something else we'll talk about today is intelligence. So there's, kind of maybe a surprising lack of relationship between intelligence and these biases that we'll talk about. So intelligence doesn't seem to reduce these biases. We'll also talk a little bit about how there's lots of different types of intelligence, and it can be really difficult to measure intelligence, especially using the methods that we have used historically. So to start, we're just going to go through a bunch of these different heuristics and biases, and I'll give you examples of them, both from the questions that you just got, and then also maybe like more real-world kind of examples. Okay, so the first heuristic or bias is called anchoring and adjustment. So anchoring and adjustment it's a heuristic that we use whenever we're trying to decide like the value of something or how much a number means. And so oftentimes if you get one number to start, like an initial number, then any subsequent numbers you encounter, your brain's going to compare it to that first one. So the first one is going to influence how you think about numbers later. So on your little quiz, there were two questions that kind of got at this idea of anchoring and adjustment. There was the one that asked about the redwood, like how tall it is. And there were actually two questions about that. And then there were also two questions asking about the population of Brazil. So you can peek at your paper and kind of see if you answered the same way that most people normally do. So this would have been question number 1 and question number 2. And then also question number 8 and question number 9. So for question number 1, just peek at your paper. How many of you put A for question number 1? How many of you put B? Okay. And then for number 2, how many of you put A? And how many of you put B? Okay, so that was close to lining up with the way that people typically answer, which I'll just show you the graph and then maybe that will make more sense. So questions number 1 and 2 were asking about the height of the tallest redwood. The first question asked you, is it taller than 1,200 feet, yes or no? A lot of you actually put taller than 1,200, which is kind of surprising to me. Most people say no to that. They say that it's not taller than 1,200 feet, because 1,200 feet is like massively huge, right? But what that does is that 1,200 feet is now the anchor that your brain is going to compare every other number to. So once you've got 1,200 in your head, then the next question, question number 2, is the more interesting one. That asks you if it's more or less than 400. Most people, what they do is they compare 400 to 1,200. Obviously, 400 is way smaller, so it makes it seem like 400 feet is really short when it's actually not. So the technically correct answer is that the tallest tree is less than 400 feet. So the tallest sequoia is actually 380 feet. But most people say that it's more than 400 when they get 1,200 as that like first number. Okay. Can any of you think of any real-world examples where this might influence your thinking? Where you get an initial number and then that changes the way that you think about later numbers?
Like the age of a couple.
Oh, that's an interesting one. I've never heard that one.
Like an old man, and then you see him with a woman that's maybe middle-aged, and you look at her like she's a lot younger, like a 30-year-old woman with 70.
Yeah. Yeah, that's a good example. So because you're thinking of like 70 as your starting age, that anything lower than that is going to seem younger than it actually is. Yeah, that's a good one. Dorian?
For marketing.
Yeah, marketing, definitely. Do you want to go, like, maybe say more specifically?
Sure. I don't know, the first thing that popped in my head was a vacuum.
Mm-hmm.
Wow, this vacuum used to be $400 and now it's only $200. Whoa.
Yeah, exactly. Yes, so we see this all the time, right? You go into a store, how many times do you see something where it's like a tag or a sign that has like the initial price and then that's slashed out and now you've got a lower price listed instead, right? And in reality, they probably never actually had it priced as the high price. They're just putting that there as like an anchoring number so that your brain thinks like, okay, 400 is a lot. Compared to that, 200 isn't that much, so I'll go ahead and buy it, right? Did you have a different one, Evelyn?
Like planning, like when you have a set budget for planning something,
Mm-hmm.
and then it's under the budget, so you're like, wow, I saved so much money.
Yeah.
Maybe you were planning for more than you needed to.
Yeah, that's a pretty good example too. Yeah, so you're like thinking a higher number, so then if you come in lower, it feels like you saved a bunch of money when really like maybe your budget was too high to start and what you spent was actually way more than you should have.
Like planning
Right.
a wedding.
Yeah, yes, yeah. Another good one is like negotiating a salary. I don't know if any of you are like at that position in your life yet where you're, applying to jobs where you would be negotiating, but that's a common thing. You go in and they tell you, okay, we're going to pay you whatever number. They actually flip it though. So that would be more like our second example. So the second example asking about the population of Brazil, it's the same idea, but it flipped it to where we started with a small number and you're anchoring from there. So let's look at that one. So that was question number 8 and 9. So for question number 8, it asked, is the population of Brazil more or less than 1 million? So how many of you for number 8 put A? Okay, that's what I would expect. So pretty much all of you said that actually it's more than 1 million. Okay, so then for number 9, it asked, is it more or less than 100 million? So how many of you put A for number 9? All right, how many of you put B? Yeah, so most of you did what the graph shows here that most people do. So in reality, Brazil's population is probably even higher than this now. I haven't updated this number in a while, but it's around like 212 million. So it's actually more than 100 million. But most people don't say that because when you start with 1 million as your anchor, then 100 million by comparison seems like a really big number. So you're like, no, there's no way it could be more than 100 million. Right? So negotiating a salary kind of works that way. Oftentimes the salary that will be posted or like the first number that the employer will say, oh, we're going to pay you 50,000, right? And in reality, they might have a budget set aside for 80,000, but they're trying to lowball you so that you will, agree to a smaller salary than you actually would want. So anchoring and adjustment is one that affects us like in our day-to-day lives a lot, actually. So anytime you're dealing with like numbers, buying something, budgeting, etc., then this is something you should think about because it might be influencing your thinking. All right, let's write that down real quick. So for most of today, we're just going to be listing off these different biases and kind of giving them a little bit of a definition. I would also recommend, I know like I write the notes up here and you're copying what I write, but it might be helpful for you for each of these to also write down an example that like makes the most sense to you. So I'll give you the definition and then you should maybe also write down an example on your own. So this first one is called anchoring and adjustment. So with anchoring and adjustment, an initial number influences your perception of subsequent numbers by comparison. So anchoring and adjustment, initial number influences your perception of subsequent numbers by comparison. And so again, then I would recommend if there was an example that stood out to you, whether it's the marketing thing or the redwood trees or whatever, maybe write that down as well just to help you remember.
Would sticker price on a car?
Yes, exactly. Yeah, that's another good one. All right, moving on. So the next heuristic I want to talk about is called the availability heuristic. This one is a little more, it's not quite as reliable in terms of whether it works or not with you guys, so we'll see if it worked. So the question that would have been relevant to this one is question number 4. Question number 4 was asking if you pick a random word from the dictionary, is it more likely that it'll start with a K or it'll have a K in the middle? So how many of you for question number 4 said A? All right, A starts with K. And how many of you said B? K is the third. All right, you all did kind of the opposite of what I was expecting, which is interesting. Does anybody want to talk through, like, what was your thought process when you were trying to answer that question? RT, you go ahead.
I always think there's a lot more words with K as a third and a lot less words that start with K.
Right, okay. Anybody else have any? Yeah.
Just reading that sentence, there were at least 3 words that had K as the third letter, and none of them had K as the first.
That's an interesting strategy that I've never heard anyone take, which like seems really obvious now that you say it, but I would have never thought of it. Yeah. Yeah.
I think how I did it was I was just trying to think of words that started with K,
Mm-hmm.
and then I compared it to words that I was able to think of that had like K as the third letter, so like asking, and then there's like kitchen.
Yeah.
And the ratio is like a lot more leaning towards K being the third letter.
Okay, interesting. So it sounds like all of you actually kind of in a way did the heuristic. It's just that the way you did it turned out the opposite from normal, kind of. So did anyone who said it starts with K, want to tell me your thought process? Yeah, Lane.
I did the same
Similar?
thing. I just tried to think of words that started with K,
Mm-hmm.
words that had K as the third letter.
Right.
I thought of more that started with K.
Okay, so yeah, so you guys are actually showing the definition of availability heuristic even if the results turned out the opposite, because that's basically what it is. So the availability heuristic refers to this idea that when you're trying to think of the probability of something, often the way you do it is to just try to think of like, what can you remember about something? And if something is easy to remember, we tend to think of it as being a higher probability. And if something's hard to remember, we tend to think of it as being a lower probability. And that can be really helpful because in a lot of cases that turns out to be right. If you can remember a ton of something happening, then that's probably because that thing happens a lot and it's really probable, right? But we've all learned now about how flawed our memory can be, and there's all kinds of things that can influence it. And so sometimes this availability heuristic can kind of lead us astray. This is actually really tricky to kind of get a technically correct answer. So I can't give you a satisfying, like, it's actually one or the other. But this graph shows how most people respond. So just so you know, these graphs come from studies that poll like thousands of people. And they do it in a much more like controlled, systematic way than just me doing it in a classroom or whatever. So when you poll lots of people, about 90% of them will actually say that it starts with K. And part of that is because for most people, it's easier for our brains to sort of categorize words by what they start with. It's like our brains sort of work almost like a dictionary, right? And if you think about it, I can go to a dictionary and open up a section of K words, but there's not a section of the dictionary that's like, okay, here's all the things that have K as the third letter, right? And so because most of our brains tend to work that way, then most people tend to answer what starts with K. Let's see. So here's another maybe like more straightforward example, and I'm guessing probably all of you will also answer this differently than thousands of people do, but let's just see. So what do you think is the most dangerous occupation? And by most dangerous, I mean that has the highest number of people who die while they're doing that job. Just shout out whatever you think. Military? What was that?
Saturation diving.
What is? I have no idea what that even is.
On oil stuff at the bottom of the ocean.
Okay, I've heard underwater welding is an answer I've heard. Okay, yeah. But I heard a lot of you say military. Very common answers, again, if you poll just like thousands of people from all over the country, some of the most common answers you'll get are cops and firefighters. It turns out at least from the research that I've done that I can find out, I think logging is actually the most dangerous occupation in reality. Which to people here, that's actually an answer I've gotten in classes before because logging is a very common industry here, right? So like you guys might actually see headlines in the newspaper about people who died during logging. You might even know some people who have died doing that job, right? What was that? Oh, yeah. That's another answer I've gotten before, too, yeah. But in the rest of the country, right, like logging is not a thing that people do in most other areas of the country. And so most people don't hear about those deaths due to logging. But if a cop or a firefighter dies on the job, then that almost always is going to make national headlines. It's going to be in the news, right? When a logger or an underwater welder or any of these other dangerous occupations, when they die, they might make regional news, but they're probably not going to get to national headlines. So when you ask people that question, what they're doing is they're just thinking in their memory, okay, what have I read about people dying on a job? And okay, there's lots of stories in my head that are available about a cop or a firefighter dying, right? So that's the answer that most people give, when actually it turns out like cops and firefighters don't die on the job very frequently at all, especially compared to some of those other occupations like loggers. So that's maybe a more like realistic, real-world example of this availability heuristic. Okay, let's write that one down. I hate how long it takes to switch. I don't know why it's always so slow. Okay, availability refers to this idea that instances that are easily remembered. So instances that are easily remembered seem to be more probable than those that are not easily remembered. So instances that are easily remembered seem to be more probable than those that are not easily remembered. This can also, this can influence our thinking in a lot of ways. And most of the examples I think of tend to go back to like the news and the way that news and media is reported, right? And oftentimes people in the news might have a particular agenda. They might be trying to, talk about instances of certain things and ignore other things. And that can really taint the way that we see the world. I think even if you think about just really broadly, like negative versus positive, what do you think is more likely to be reported? Something negative that happens or something positive that happens? Right. If there's like a crazy storm or a, natural disaster or like a mass shooting, right? All those things are going to be reported. But if there's like a day where it's just like, oh, nothing crazy happened in Longview today, like that's not going to be an article in a newspaper, right? And so because of that, we often tend to see the world maybe more negatively than it actually is because we have all these stories available in our mind of all the negative, terrible things that are happening. So it can really influence the way we perceive the world, basically. Okay. So some of these, just so you know, I don't have an example from the little quiz thing we did at the beginning, just because they're difficult to like build an example for in that kind of format. And so one of those that I didn't have an example for is anecdotal fallacy. So anecdotal fallacy is where you make decisions based on like a single person's story rather than looking at large-scale data. So, you know, this again, something we do all the time. You know, I've heard of people who are smokers, for example. My mom has smoked for like her entire life, and sometimes I'll try to convince her that she should quit because it's bad for her. And sometimes she'll tell me like, okay, well, the person who lived to be the longest, there's this woman in France who lived to be like 120, and she smoked up until the day she died, right? Or there's like other people she can point to that, you know, they turned 90 before they passed away, even though they smoked their whole lives. So that would be an example of anecdotal fallacy. My mom is looking at one example of a person who like happened to live, but ignoring all of the vast numbers of studies that have all this data that show if you smoke cigarettes, you're going to almost certainly get lung cancer at some point, or at least there's a high correlation between those, right? I don't know, other examples, a lot of times you might hear about people who are super successful, even though they dropped out of college or they dropped out of high school or whatever. Right? And so you hear that one story about like, oh, this person became a millionaire even though they dropped out of college. And so you think like, okay, maybe it's a good idea to drop out of college. But if you look at the actual statistics, you look at large scales of populations of people, most people who drop out of college are going to be less successful than those who go on to finish college, right? So, I mean, we could go on and on. There's probably lots of other examples, but again, it's just where you take one, it's like cherry picking one example that fits the narrative or whatever, and ignoring all of the data. So again, there wasn't really one of those on your quiz because I don't know how it'd be difficult for me to write a question in a class like this that would fit that. Let's write down what it is though. So anecdotal fallacy. There's actually only one N, sorry. It's A-N-E-C-D-O-T-A-L, anecdotal fallacy. So that's where making a decision based on a single story while ignoring large-scale data. So anecdotal fallacy, making a decision based on a single story while ignoring large-scale data. All right. The next one is base rate fallacy. This one's very mathy, which I know a lot of people get really anxious hearing about math. So that makes it maybe one of the more difficult ones to explain. But basically, base rate fallacy it's again when we're trying to think of the probability of something happening. A lot of times what we do is we'll ignore what's called base rate information, which base rate refers to just like the probability in the general population of something. So I'll give you a couple examples and hopefully that'll make this clearer. One of the examples came from your questions that was asking about, it was like one that looked like basically a word problem that was asking about like the different cab companies. There were 2 cab companies. There was like a car accident that someone witnessed. And then they were tested to try to figure out is it a blue cab or a green cab. Does everybody kind of remember that question? That was, let's see, question number 12. And again, you were supposed to respond with something between 0 and 100%. How many of you put something over 50%? So that was for number 12. Okay, how many of you then were less than 50%? Okay, so for those of you who were over 50%, again, let's think about what was your thinking for that, if you can remember. Yeah, Paul. Okay, yeah, so you basically went just like straight with her accuracy rate.
Yeah.
Okay, so for those of you who put less than 50%, what was your thinking? There were only a few of you. Yeah, RT.
Because there's like 5% left over. So
Yeah, so I think you were looking at like the actual number of cabs. Is that what you're looking at? There was like 15% of the cabs were green and 85% were blue or something. My next slide has some of that information, so maybe that'll be helpful. So yeah, so the base rate information in this question was the part that said that 85% of the cabs are blue, 15% are green. So that's your base rate because that's like, you know, the base number of cabs in the whole city. So just the probability that she would have even encountered a green cab? Yeah, the probability that she would have encountered a green cab is only 15% because only 15% of the cabs in the city are that color, right? So that's the base rate. But most people ignore that and they just go with that second number, which is her accuracy rate of 80%. I am not a math teacher, and again, like this one, I don't know if there's necessarily a satisfying answer. Probably the best answer would be to take 80% of 15%. And then, you know, that might be a better answer than any of the others. But the main point, it doesn't really necessarily matter for a lot of these questions what your answer is. It's more like what is your thinking? What is your logic to arrive at that answer? And again, most people ignore base rate. Let me give you another maybe concrete example. So let's say that I noticed that in my classes, girls or women tend to speak up and ask questions more than men do, okay? And let's say I notice that and I take that as like some indication of, you know, something that describes the different genders or whatever. Can you guys see maybe something that would be wrong in my line of thinking if you even just look around this classroom right now? Exactly. So in psychology, it turns out that there's a huge gender disproportion where women are much more likely to be psych majors than men, and they're much more likely to take psych classes. And so in most of my classes, I have about 80% women and 20% men at the most. And so if I just ignored that base rate information, I think like, okay, men never speak up in my class, I might make some really, you know, poor judgments about men that would not be true or based in reality. They're just based on me ignoring this base rate information. Okay, so base rate information is actually really important. I'm going to give you one more example that's also very, very math heavy. Don't worry, this is not like something I would ever test you over, so don't worry too much about the numbers. It's just like, I think this is a very good example of how important this base rate information can be. So I'll read through this and we'll kind of think through it. So here we have a disease that affects 1 in 1,000 people. So the disease itself is very, very rare. Let's assume we have 100,000 people that are tested for that. And so we expect 100 of them have the disease. That means 99,900 don't. The accuracy rate of this medical test is 95%. So let's say that you're tested for this disease and you get a positive diagnosis. What do you think the chance is that you actually have that disease? So just shout out your answers again from 0 to 100%. What do you think the probability is? Okay, 95. How many people feel like that's probably the answer? That if you get tested for this, it has a 95% accuracy, especially if you weren't in this class right now where you know that I'm asking you questions that trick you. If I just asked you that out of context and you got this information, how many of you would think probably like 95% chance you have that disease? Probably most of you, right? It turns out, and again, we don't have to worry too much about the actual math, but I have a table here where you can check it if you care. It turns out if you have this set up, these numbers, and you get tested and you have a positive test, there's actually only about a 2% chance that you have that disease, 1.9%. And the reason is because the numbers that you have to look at is like, so this is showing you, this table is showing you the people who actually have the disease, whether they have it, yes or no, and then if you get a positive or negative result, okay? The chances are that you do not actually have the disease. So most people are going to fall within this column, right? For you to actually have the disease and test positive, there's only 95 people out of 100,000 that would have the disease and test positive. So that's only 2%. So that's one of the reasons that especially if you get diagnosed with like a really rare disease, it's always a good idea to get a second opinion, to go to another doctor that's independent, that's using a different lab to do their testing, and get that test again just to make sure, to verify, because these tests do sometimes give false positives. So again, but most people are going to ignore all the numbers in this question except for this one. Most people are going to fixate on that 95% and think like, okay, there's a 95% chance I have it, when actually it's only 2% chance. So in really like important areas of our lives, this base rate fallacy can play a role. So let's write down that one. So I'm writing down base rate fallacy. So base rate fallacy is failing to understand the true probability of something due to ignoring the base rate. So base rate fallacy is failing to understand the true probability of something due to ignoring the base rate. Base rate fallacy, failing to understand the true probability of something due to ignoring the base rate. All right. The next one I want to talk about is confirmation bias. And out of all of these, like if you could just remember one of these biases, like going forward out of this class for the rest of your life, you know, if I could like force you to remember one thing from my class, I think this would be one of the big ones, is confirmation bias. So confirmation bias is this tendency that we all have to look for information that proves us right and ignore anything that proves us wrong. Okay? How many of you like to be wrong? How many of you have ever like gotten into an argument with someone and something happens and you realize like, oh shit, I'm the one who messed up, I'm wrong? How many of you like that feeling? How many of you like the flip of it? You get into an argument with someone and like you know that you're right, and maybe they come to you later and they tell you like, okay, you were right. How many of you like that feeling? I like that feeling, right? None of us like to be wrong. We all enjoy being right, and because of that, we often have this confirmation bias. Okay, so there were a couple of questions that I asked you to test this. So the first one would have been question 11. So question 11 was the one that had like the ER85 cards that you're supposed to flip. And that was testing like some rule about if there's a vowel, then there's an even number. Okay. How many of you, for question number 11, put E and 8? All right. Did any of you put, so who put something different than that? Okay, let's start Evelyn. I think I saw your hand go up first.
I put only E because it doesn't say anything about the rule being reversed in any way. So
Okay.
It doesn't say that even has to have a vowel.
Right.
Odd has to, so I just put E.
Okay, you're on the right track. You didn't quite get to the right answer, but your thinking is in the right way, which is good. Yeah, Ariana, what did you put?
All 4 of them.
You put all 4 of them?
Well, because if you flipped one of them, maybe it had like a vowel and maybe number, but the other one that's an even number, then it's a vowel.
Okay, all right.
And maybe one of the odd numbers had a vowel.
Okay. Lane?
I had E at 8 and 5.
Okay, E, 8, and 5. Did anybody put just E and 5? Okay. E and 5 is the technically correct answer from like a logic perspective. So let's just think about this a little bit. So what were they again? ER, 8, and 5. And the rule said if it has a vowel, then it should have an even number on the back. So Evelyn's line of thinking is totally correct. You definitely need to turn over E, because if you turn over E and there's an odd number, then you've just proved that the rule is wrong, right? If you turn this over and there's a 3, let's say, then that means the rule's wrong, that vowels do not have even numbers, they have odd numbers. Okay, so that one's important. You also, though, need to turn over 5, because if you turn over 5, let's say you turn that over and it has an E or an A or whatever, then that also has just disproven the rule. You've proved that something with a vowel actually has an odd number instead of an even number. But the other ones don't matter. So, if we turn over R, doesn't matter if it has an odd or an even number, because the rule doesn't say anything about consonants. We don't care about that. right? Also similarly with 8. So like Evelyn was saying, the rule is not reversed. It doesn't say that, so it says that a vowel has to have an even number, but it doesn't say that an even number has to have a vowel. And those are different. It's kind of like saying, if I'm in Longview, I'm in Washington, right? Which is a correct statement. But that doesn't mean that if I said, if I'm in Washington, I'm in Longview, right? If I'm in Washington, I could be in Seattle or Spokane or a million other places. So it's kind of funny, like if we make this more concrete, it can be a little bit easier to understand. Let me think about it for a second to make sure that I get it right. So let's say like you're a bouncer at a club and you have to check IDs and make sure that like if someone is drinking alcohol, they have to be over 21, okay? So let's change up these cards. It's going to be the same logic. I'm just going to change the like specifics of it. So if someone has alcohol, so let's say we have a card with vodka. We have, let's say this is someone who's 35. This marker's dying. So we have vodka, we have 35, we have, I don't know, Mountain Dew, and then here we have 16, okay? So these cards, instead of having letters and numbers, they have drinks and ages, okay? So if you're a bouncer and you see these, you see a card with vodka is the drink, you see a card with 35 is the age, you see a card with Mountain Dew is the drink, and you see a card with 16 is the age, and you want to see, okay, if I flip this card, what's on the other side, what drink or age, then which of these are you going to flip over if you're trying to verify? Vodka and 16, right? You want to make sure the person drinking vodka is over 21, and you want to make sure that the 16-year-old is not drinking alcohol. Okay, so if we just make it like more concrete instead of abstract, it's the exact same setup, but now all of a sudden it makes sense in our brain. Okay, so what does this have to do with confirmation bias, right? So it turns out most people say E and 8 because what they want to do is prove themselves right. The rule says if there's a vowel, there has to be an even number. If you turn this over and there's a vowel, it doesn't actually help you prove anything, but it feels like you're proving yourself right, basically. Okay, the next one that tested confirmation bias was the last question, question 14, which is the one where I gave you 3 numbers and then I made up a rule. So anybody want to take a shot at guessing what the rule in my head was? Yeah, RT. Yeah, I see what you're saying. So like you start with whatever the first number is, you're gonna square that, right? That would be, so if it was 3, it would be 9 and then 81 or whatever. Is that kind of what you were going for? Okay. Kristen, did you have something?
Adding the number 2 to each number in the sequence.
Okay, so just increasing by 2. All right. Anyone have a different one?
Everyone doubles.
Doubling it. Okay. Evelyn?
Like below a certain number, like below 50 or below 100.
Okay, interesting. Ariana?
It's adding 2 to the number that you're adding to each number.
Okay, so adding 2
You're
to...
adding 6, the next time you're adding 8, the next time you're adding 10, the next time you're adding 12.
Okay, I see. Interesting. All right, so none of you got it. So the rule was just that the numbers have to be going up. That's it. That's all the rule that was in my head. I think I even have it. Yeah, I have it on the slide, so you know, I didn't just make that up just now. That was what I had in my head to begin with. But most of you, so here's the interesting thing. There were a couple of you who wrote down 3 sequences and had me check right away, but that was very rare. Almost all of you wrote down one sequence that you thought fit the rule in your head. So you came up with a rule in your head, and you're like, I'm going to write a number that fits that rule, right? And then as soon as I said yes, you latched onto that. Okay, she said yes, so I must be right. Okay? The better way to approach this is to try to prove yourself wrong. So if you think that the answer is that I was doubling it, then what you should have done is wrote a sequence that doesn't double, right? Write a sequence that's wrong, that goes against your rule. And then if I came around and said yes, then I've just proven to you that your rule is wrong, which is good because now you can update your rule and come up with a different one and try to be right. Everybody get what I'm saying? So we have this tendency to just seek out information that proves ourselves right. when in a lot of cases, it'd be better to try to prove ourselves wrong, because if we prove ourselves wrong, then we can improve, right? If I know I'm wrong about something, then I can go and research that better and try to get to the point where I'm actually correct and I'm actually getting to the truth of something. Okay, given all that, any of you have any real-world examples of confirmation bias? I've given you a lot of examples. Do you have any?
When I built my computer, it's like, oh, a lot of people can do this. It's easy. I thought it was going to be super easy. And then I realized there's probably a big portion of people that have a really hard time with it.
Yeah,
and
yeah.
It took me like 3 days, and I was getting really frustrated, and I was like, oh, this sucks. But
Yeah,
yeah,
yes.
looked at the whole thing, and then instead of looking at, I just looked at the few people that were really good at it, and
Right.
look at all the other people that just
Yeah,
were
yeah.
starting.
That's interesting. That fits really well with another bias we're going to talk about in a second, but I can see how it's also like confirmation bias. Like you think, you have an idea in your head, you can build a computer, and you look for information that proves you right, that it's going to be easy and you can do it. Yeah. Paula?
I don't know if this has anything to do with it, but like that Schrodinger's cat, like if you put him in a box or something that'll kill it and sell it, you won't know if
Yeah.
it's dead or alive or both. Is that like? did you
That's
know
interesting.
that?
I could see that. I could see you. Yeah, I can see how you're making that connection. Yeah.
Because you won't. Yeah.
Right. Yeah. Yeah. Evelyn?
You're like sick and you Google it and you have all the symptoms and you're like, man, I'm gonna die now.
Yeah. Yes. You like very quickly convince yourself you have like terminal cancer or something because you have one symptom and like that's in your head. Yeah. Yeah. Addison?
Well, for me, it's like Taylor Swift Easter eggs. Like, people are like, oh, what TV's gonna come out, and then it's not after, then you're like, oh, but you really believe it.
Yes. Yeah. Yeah. You have a theory about something. I do that all the time with like TV shows or books or something where it's like you come up with a theory of what's really happening and then you try to find like only the details that fit that. Yeah. Another big one I would say is like political stuff. We don't have to get into anything specific because that could like instigate some fights, but you know, we often get into like our little bubbles where we only seek out other people who tend to agree with us in our real life and also especially online, right? And so if you have an idea about a particular candidate or about something going on in the world, then you often will find information that agrees with that and ignore anything that is telling you you're wrong. Which I think we all probably could, you know, see the kinds of issues that type of thinking can create, right? It leads to a whole society that's like divided and, yeah, really toxic, basically. So again, out of all of these, I would say confirmation bias, I would encourage you in your real life as much as possible, if you hold an opinion about something, especially if it's something you think is important, intentionally try to prove yourself wrong as much as possible. And hopefully, eventually, you'll get to a point where, like, you can't prove yourself wrong because you've actually arrived at the truth, and that would be great. Okay, so confirmation bias. Let's write this down. So confirmation bias is ignoring any information that conflicts with your beliefs So it's ignoring any information that conflicts with your beliefs and selecting only information that agrees with you. So confirmation bias is ignoring any information that conflicts with your beliefs and selecting only information that agrees with you. Okay. Next up, we have a couple more that I didn't have examples for on your quiz. And some of these might start to sound kind of similar, just so you know, like there's overlap between these biases and heuristics. It's not like there's super clear boundaries all the time between them. So choice supportive bias is another one. And it's kind of similar to confirmation bias, but choice supportive bias requires that you first put resources into something. Usually it refers to buying something. So choice supportive bias is basically where you buy something and then you convince yourself that that was the best decision you could have possibly made. So you focus only on all the positive aspects of whatever it is and you ignore all the negative things. But again, it requires that you put resources into something first. So I don't know, let's say maybe you buy a car. You spend a lot of money on that car, and maybe it turns out that there's all kinds of things about that car that are not great, that you maybe should have put more time and effort into researching first. But because you've already spent the money, you tend to ignore those things and focus on like only the positive aspects of this thing that you've bought or this choice that you've made. So that's choice supportive bias. So it's kind of like confirmation bias, but again, it requires that you've like put resources into something first. Next one is the familiarity heuristic. So familiarity heuristic is very simple. It just refers to this fact that we tend to prefer things that we have encountered in the past or things that we're familiar with. So this is one that, again, is used in marketing all the time. So if you think about it, like right now, look at all the brands that are like prominent. It's easier for me to see maybe in the front, but if you like stood in the front right now and looked, there's just like brands everywhere. There's on laptops, they're on t-shirts, they're on water bottles, right? They're everywhere. And the reason that brands like to put their logos everywhere is partially because of this familiarity heuristic. So the more that a brand is out there, the more you see this Apple logo everywhere, it becomes more and more familiar to you, and you will start to actually prefer it because of that familiarity. So that's the familiarity heuristic. And then the ostrich effect is kind of the it's again sort of similar to choice supportive. Ostrich effect is where you ignore potentially useful negative information. The main difference between the ostrich effect and the choice supportive is ostrich is usually before you've made the choice, and choice supportive is after you've made the choice. So let's say you're trying to decide on something, you might, focus entirely on the positives and ignore all the negative aspects. I'm trying to decide if we need to write all those down. So I have extra kind of heuristics listed that we don't have examples for. And I don't think there's anything on the quiz that would test you. So I think I'm gonna move on from those, especially because they're so similar to confirmation bias. Okay, next one is called the clustering illusion. So clustering illusion, this one was tested with a question that asked about like the coins, the coin toss. So let's see. So that was question number 5. So let's peek at your answers real quick. How many of you for question number 5 put A? All right. How many of you put B? Okay. So you might have recognized that there was kind of a trick to that one. So that was the one that asked, like there was 10 coin flips and there were a bunch of tails all in a row. And then it asked you, is the next one more likely to be heads or tails? And the majority of you said heads. So any of you know kind of the trick to that question or why it's a trick? Yeah, Dorian.
Put a bunch of tails next to each other to make you think, well, the next one has to be heads.
Right. Yes, but in reality, it doesn't have to be heads, right? So coin flips are completely independent events, right? So if I flip tails a bunch of times in a row, that has no bearing on the next flip. The next flip has an exactly 50% chance of being heads, 50% chance of being tails, right? Yeah, unless there's something, it's weighted or something like that, right? But assuming that it's like an actual random toss or whatever, then there's a 50-50 chance that it's going to be heads or tails. And yet, like 90% of you said heads as the answer for the next one. So this is the clustering illusion. There's different names for this one. So sometimes it's also called the gambler's fallacy. You might have heard that term before. So gambler's fallacy, it's called that because often gamblers will fall into this tendency where something like that happens. There's a dice roll that's a 1 a bunch of times, and so then they think, okay, the next roll has to be a 6 or a high number, right? Or whatever. The coin was flipped this many times, so it has to be a heads next. But in reality, it doesn't. So clustering illusion is basically where we see patterns that don't exist in randomness. So we're trying to seek out patterns even though the thing that we're dealing with is completely random. So we should write that one down. So the clustering illusion. Clustering illusion is seeing patterns that don't actually exist in random data. So clustering illusion is seeing patterns that don't actually exist in random data. It turns out in general, human brains are like really, really bad at understanding randomness or generating randomness. Like if I asked you right now to just start naming off random numbers, give me 100 random numbers, right? Almost certainly, each of you individually would fall into some kind of pattern while you're giving that random. Like you wouldn't give me something that's truly random. There'd be some sort of pattern to it, even if you don't realize it. We also, any of you, I don't know, listen to like music playlists that you shuffle, you put in random. Do those feel random to you most of the time? Or do you ever have that moment where you feel like, okay, this is not truly random. It's giving me some sort of pattern. It's basing it off of, you know, what I listened to most recently, or it's playing songs in a row that are, you know, maybe in the same mood or by the same artist or whatever. Actually, I've read that Spotify in particular, they've had to tweak their random algorithm to not be truly random, because if they make it truly random, people don't feel like it's really random. They feel like there's a pattern there that doesn't actually exist. So they like tweak it so that it's not truly, they like do other things to it to make it feel more random by making it less random, which is super paradoxical. But it's because our dumb human brains are very bad at understanding randomness. And so clustering illusion is just one example of that. Okay. Next up, I don't think I tested this one in any way. But the next one is the bandwagon effect. This is, again, probably one you've heard of to some extent. Bandwagon effect just refers to the fact that we tend to do things if more people are doing the same thing. So kind of jumping on the bandwagon. If everyone we know starts to like a particular type of music or wear certain kinds of clothes or whatever, then often we're more likely to also make that same decision. This also plays a huge role in politics as well, right? We get a certain presidential candidate that gets lots of support behind them, and it feels like everyone in your party is going to vote for them. Then you decide, like, okay, I might as well vote for them too because everyone else is doing it, so why not? So that's the bandwagon effect. Again, not something I tested because it's kind of hard, but we should write that one down. All right, bandwagon effect. Let me think of the best way to write this. Bandwagon effect, basically probability of making a specific decision. So probability of making a specific decision increases the more other people make that same decision. So bandwagon effect, the probability of making a specific decision increases the more other people make that same decision. Okay. All right, the next one is called survivorship bias. I did test this one. This one is another one that's hard to test. I don't know if it's very effective the way that I questioned it, but we'll see. Survivorship bias is where we focus only on examples of things that survive or succeed, and we ignore all of the ones that fail. So the question that I asked you that gets at this potentially was question number 7. That's the one that asks, like I said, there's an earthquake and a bunch of buildings are damaged. The ones that are still standing had, damage to the upper portion of the north wall. And then I ask you which part of the building should be reinforced. So anybody want to share what you put for that one?
I put the
Okay. Middle. Any?
I put upper because that was the part they said got damaged.
Okay. All right. Anyone else do the same thing? Say the upper part.
The north part.
Okay. Yeah. So that's kind of the answer I would expect based on the survivorship bias. But again, I don't know if that question is like great for testing this. So yeah, that refers to this idea that we focus on the samples that survived and ignored what failed. So let's think about this logically. The buildings that actually stayed standing are the ones that had damage to the upper part. And so if damage to the upper part is not enough to collapse the whole building, then maybe the upper part actually isn't that important and doesn't need to be reinforced, right? So instead of focusing on the buildings that survived, it's actually better to focus on the ones that collapsed and try to figure out what happened to those so that we know what to reinforce in the future, right? Does anybody know where the first survivorship bias idea comes from? It's a story that's kind of well known, but maybe not, with like the airplanes in World War II, maybe something like that. So yeah, and I hear different iterations of this story, and I don't know which one is true, but it proves the point at least. Whether it's true or not, it kind of illustrates it. So there's this story that the first person that came up with this idea of survivorship bias was like an engineer studying planes. I think it was in World War II. It might have been some other war. And basically, like, the planes would come back. I'm going to draw a plane, which is going to be not great. It's got a tail. I don't know. Whatever. Okay, we've got a plane like this, right? And the planes would come back, and let's say like all the planes that come back would have bullet holes, I don't know, all over the wings. Okay, so they would see these planes come back with these bullet holes in the wings, and they would decide like, okay, we need to reinforce the wings. We need to build that up to be stronger. We need to put more metal or, harder metal or whatever. So they would do that, and then they would look like, does that increase or decrease the amount of planes that are going down and crashing? And they found that it had basically no effect, that reinforcing this part with the bullet holes didn't do anything to decrease plane crashes, right? Anybody know why?
Ones that were shot elsewhere crashed.
Exactly. So these are the planes that are making it back. So if they're making it back, then that means probably getting bullet holes in the wings is not enough to bring them down, right? So what we need to do is go find the planes that crashed and look at where they got the bullet holes and then reinforce those parts, right? So that was one of the first. Again, I don't know if the whole story is true or if it's something that, I don't know. But yeah, but that kind of proves this idea of survivorship bias. Let's think of some real world examples where you might see this. And some of this, again, overlaps with confirmation bias. I think that's why I said it's so important, because it plays a role in all of these. But let's say, again, you focus on, going back to the example I gave you with the millionaires that dropped out of college, right? If you only focus on the ones who survived that process, who dropped out of college and then went on to be successful, and you ignore all of the people who then failed, right? Same thing with the cigarette smoking. If you only focus on the people who survived the cigarette smoking and ignore all the people who have died from it, then that would be survivorship bias. I sometimes see this now with people getting really nostalgic about old appliances or old cars. I don't know if you guys ever see that, where someone will post oh, look at this refrigerator from the 50s and how fancy and nice it is, and why don't we make refrigerators like this anymore? But think of all the refrigerators from the 50s that are in a landfill somewhere and didn't function, right? If you only look at the one that someone kept in pristine condition and kept until now, then you're ignoring all the ways that those fridges could possibly fail. I think that also relates to Ezra's thing about the computers. I think he's asleep though, but okay. So that's survivorship bias. Okay, survivorship bias. Survivorship bias is focusing only on examples that have survived or succeeded. So focusing only on examples that have survived/succeeded while ignoring those that failed.
survivorship?
Yeah. Survivorship bias, focusing only on examples that have survived or succeeded while ignoring those that failed. All right. I know this is a lot of these back to back. We've got about 4 more. All right, next one was hindsight bias. So hindsight bias is where we tend to think that people in the past should have made better decisions based on information that came after that decision was made. Okay, so this is another one that plays a huge role in like political things. So, you know, maybe there's some sort of natural disaster and everybody says like, oh, well, we should have done X, Y, and Z. We should have reinforced these levees and we should have built our buildings this way, etc. But you're only saying that after you have the information that comes from the disaster that happened, and there's no way probably that that disaster could have been predicted, right? So you're trying to basically go back in time and make better decisions with future information. This is one I tried to test, but again, it's one that I don't know if it would have been very effective or not. So this is the one where I had each of you get different versions. So this was question number 6. So let's look at your questions. Question number 6. Let's see. Okay. So let me try to remember. I had the left side answered first, right? Yeah. So for people on the left, how many of you said A to question 6? How many of you said B to question 6? Okay. All right, people on the right, let's ask you. So people on the right, this is again number 6. How many of you said A? All right, how many of you said B? Okay. So kind of what I was expecting. So the way that I phrased that question, do I have it on the slide? So the question was exactly the same. It was like talking about, I don't remember the person's name, but they were going to go to this party instead of studying. Did they make a good choice or a bad choice? The only difference was that the people on the left did not get the information that ultimately she did well on the exam, which all of you at the right did get that. So there was just that one sentence added for the right that said ultimately she did good on the exam. So what I was expecting to happen, you guys did what I was expecting. You all said it was a bad choice that she goes to the party. I assumed that those of you who got the information that she did well on the exam would say it was a good choice. Most of you didn't, so it didn't quite work, but that's okay. But kind of the same idea, right? It's like once you have the information that she did well on the exam, then that's going to color your information of the decision she made in the past, even though when she went to the party, she had no idea how she was going to do on the exam, right? So that would be an example of this hindsight bias. We went through several of them. We just had a few left, I think 3 more. So we'll go ahead and go through those. And then also, like I said, we'll talk a little bit about intelligence today as well. So the next bias that we had not gotten to yet, or the next bias, is the conjunction fallacy. I don't know if any of you kept your little notes from the quiz thing that we did last time. If you happen to have those, then maybe pull them back out just so you can see how your answers lined up with kind of what's expected. The conjunction fallacy was measured with a question. There was one that talked about, I don't remember the name, I think it was Kristen maybe? Yeah, Kristen is the name that I used. So it talked about this woman who, is politically active, was at the Women's March, all these other details about her, and then asked you which is most probable, that she's a teacher or that she's a teacher and a liberal Democrat. Let's see. I don't know if any of you have your thing out. That would have been question number 3. So for question number 3, how many of you said A, if you have your paper, and how many of you said B? Okay. All right. So you guys were very intelligent and did not fall for the trick that most people fall for, which is great. I just said intelligent, even though, like I said before, none of these actually have anything to do with intelligence. What most people say when given this question is actually they say A, which would be that she's a teacher and a Democrat. So most people tend to make this mistake that's called the conjunction fallacy. This one actually is kind of tapping into multiple biases, really. So one of the biases I didn't write down that this is playing on is what's called the representative heuristic, which is really just a fancy name for stereotyping, basically. So representative heuristic says that whenever we learn like one detail about someone, we kind of internalize that detail and make a judgment about what they are, sort of based on what that item represents, right? So when you're reading this and you read that she's concerned about issues of discrimination and social justice, most of us probably would associate that with being a liberal Democrat. And so then you think from that one detail, like, oh, she must be, really Democratic or whatever. But the more interesting thing I think with this question is, like I said, what's called the conjunction fallacy. And the conjunction fallacy is where we choose to believe that two things happening simultaneously is more probable than just one of those things happening. And mathematically, that just doesn't make any sense, which it seems like a lot of you kind of tapped into. So if you think of kind of like the Venn diagram of people who are teachers and then people who are, liberal Democrats, there is going to be some overlap somewhere where some people are both of them. But that sliver of people that are both of them is always mathematically going to be smaller than the people that are just teachers only. And so the logically correct answer to this one would be to say that, she was just a teacher, which is what most of you said. So again, this one didn't quite work the way that I would have expected it to. But anybody have any thoughts, like anything you were thinking through when you answered that question, if you remember from Monday? Yeah, Dorian.
I remember being confused because it was such a weird question.
Yes, yeah.
Why does it matter?
Yes, yeah. Which, I mean, the entire point of the question is just to test this bias, basically. And I'll reiterate, too, these are not questions that I wrote. I didn't come up with this. This is something that came from, like, a test of people testing these biases. Any other thoughts anyone had while you were answering this question? Did any of you think of it this way?
Yes.
Okay. Good. All right. Let's write down the conjunction fallacy real quick. I think I need, at this point, I think also that question is kind of old. I think I actually did, even though I didn't write the whole question, I think I updated it to talk about like the Women's March, because the question, the way it was phrased before, talked about some event that was like way old. I need to find a better one that's maybe not so obviously political, because I feel like that often like tips people off to think a different way. But yeah, anyways, conjunction fallacy. So conjunction fallacy is falsely believing that the probability of two things happening together is higher than one of them happening alone. So conjunction fallacy is falsely believing that the probability of two things happening together is higher than one of them happening alone. All right, the next one is called the sunk cost fallacy. This one I did I had a question on there that tested this one, but it's very difficult to do this one through just a question on a quiz type format. So I'm going to guess that probably this wasn't super effective. But sunk cost fallacy is basically whenever you have already put some sort of time or resources into something, you become so committed to that even if it would be better for you to like abandon ship and jump off and do something else, you still stick with that option just because you've put all these resources into it. So the question that I asked, I think there were actually two of them. One of them was asking about like a Halloween costume where you cut out stars and you already put time into doing that, and should you leave them on or take them off? And then one of them was talking about like you're trying to get from one place to another and you've already planned out a route because you didn't have the internet, and then the internet comes back on. Do you stick with the route you chose, or do you like go with whatever the internet is telling you to do? Let's see, in my notes that says that's question number 10 was the one about the Halloween costume. So we can peek at this again. For question number 10, how many of you said A? So A was that you would keep the stars. How many of you said B? All right. This is from last time. This is asking the questions from Monday's quiz.
Oh, okay, cool.
And then for 13, kind of similar. How many of you for 13 said A? And how many of you said B? All right, so yeah, so you guys did the opposite of what the sunk cost fallacy said. But again, I think it's hard to test. Like, I'm asking you to imagine that you spent all this time cutting out stars. Your response might be different if I actually like made you sit down and spend an hour cutting the stars out, right? Like if you actually invested that time and resources, then your behavior might be different from just asking on a quiz. Well, all right. Yeah, I think it's just water. Okay, so in real life, though, there's probably lots of instances where you have given into this sunk cost fallacy. We can think of it, so, maybe like relationships, for example. Any of you ever stayed in a relationship maybe a little longer than you should have? Yeah. Same. And oftentimes it's because of the sunk cost fallacy, right? You might recognize like, okay, this relationship is not going great, this person isn't treating me well or whatever, but I've already wasted X number of years or months of my life and I don't want to waste that or throw that away, so I'm going to stick it out and hope that it works, right? That would be one example of sunk cost fallacy. Maybe if you have, I don't know, like a car that is breaking down every week, and you've put thousands and thousands of dollars into fixing this car, and logically it'd probably be better to just like sell it off, like the value of it, economically it would be better to just sell it and get something new, but you've already put so much money in this car, you don't want to get rid of it, right? All of those would be examples of sunk cost fallacy, like, I already wasted all this time or money or effort, so I'm not going to abandon it now. Anyone have any other examples you can think of sunk cost fallacy? Yeah, Dorian.
An example of sunk cost fallacy.
Yeah.
Okay, that's what I thought. Sorry,
Yeah.
my brain working good. Buying a movie ticket and seeing a movie and having the movie suck, but like, well, I already bought the ticket, so might as well keep watching.
Yeah, yes, especially when it's like a 3-hour movie or something and you realize you're only halfway through and it's like, maybe I should leave, but no, I already bought it and sat here this whole time, so I might as well. This is one I maybe shouldn't say given my position, but some people might, get into a college program and think like, oh, this is going to be great for me and it's going to help me, get a career and stuff. And halfway through, maybe you're not doing so great, maybe failing classes, maybe wasting a lot of money on tuition, but you feel like, okay, I've already put a year or whatever into this. Should I keep going? I hope that's not hitting too hard for any of you. But yeah, so again, something you should maybe stop and examine. Like maybe it'd be better to quit sometimes. I think part of that is so deeply ingrained because we're taught that like quitting is always bad. But I think there's cases where actually quitting is probably the best thing you can do. So yeah. All right, let's write down some cost fallacy.
You already do the definition for sunk cost fallacy?
No, that's what I'm about to do right now. Sunk cost fallacy. So sunk cost fallacy is refusing to abandon a choice. So refusing to abandon a choice, even if doing so would be better for you. Because you have already invested resources into that choice. So sunk cost fallacy is refusing to abandon a choice, even if doing so would be better for you, because you have already invested resources into that choice. So sunk cost fallacy, refusing to abandon a choice, even if doing so would be better for you, because you have already invested resources into that choice. All right, and then finally, the kind of grand bias that, serves over all of these is what's called the bias blind spot. And the bias blind spot just refers to the fact that we often are not aware that we have these biases. It's usually much easier to see biases in other people than it is to see in ourselves. So, and again, I'll talk in just a second about how that's not really correlated with intelligence or any of the things you might think it would be correlated with. It's just kind of the human condition, basically. So we'll write that down. So bias, blind spot. Bias blind spot is just a failure to notice your own biases. I know. Biases sounds weirder to me. Biases. It's a failure to notice your own biases. So something I would strongly encourage you to do, if you don't already, is to reflect on your beliefs and your attitudes and your opinions and think about, is it possible? I think always starting at least with that question, is it possible that I have a bias, in this opinion or whatever? And if you do, then, what's the repercussions of that? And, kind of like allow yourself to follow that line of thought and try to identify where you may have biases. Because I guarantee you have them somewhere. I do too. Everyone does. They're just very difficult to see sometimes. All right, so as I've alluded to multiple times, there's evidence that these biases have nothing to do with intelligence. I think a lot of people tend to falsely believe that like if you're, really smart, you have a high IQ, then you're going to be less likely to fall prey to these biases. You're going to be more logical and rational. But actually, there are lots of studies that suggest that that's not true. And if anything, sometimes the opposite can be true. So there are studies that have been done where basically they do kind of what I did with you at the beginning of class on Monday. So they give people little questionnaires that try to test and probe at these biases. And then they also give IQ tests or some other sort of intelligence measure alongside that. And then see, the people who score high on IQ, how do they do on these biases, et cetera. And a lot of those studies have found that basically there's no relationship between intelligence and biases, like I said. Some have actually found that people who are highly intelligent are more likely to have biases than people who have less intelligence. And part of the reason is that so a lot of times what our brain does is we make a decision kind of unconsciously. So a lot of the decisions that we make are done, before the activity in the cortex of the brain. They're done more in like the amygdala and the kind of lower structures. And then the job of the cortex is to tell ourselves a pretty little story to justify the choice that we made, to make it sound like what we chose was rational. And someone who's intelligent is going to be a lot better at constructing those stories for themselves. So they might do something from a place of bias, but then they're able to rationalize it and make it sound better because of their intelligence. So then they're more likely to kind of stick with that bias instead of realizing that there's something wrong. So in general, all of that is just to say that, if you realize that you're using these biases, that doesn't mean that you're stupid. That doesn't mean that there's anything wrong with you. It just means that you're human, basically. Okay, so now let's get into a little bit of talking more about intelligence, like what exactly is intelligence, how do we measure it, etc. So one of the main things I want to iterate is that there are lots of different types of intelligence. So, there's not just one thing that's intelligence. Instead, there's multiple types. And there are a few different theories that try to categorize those types of intelligence. We're going to talk about 3 different theories that look at it from kind of different perspectives. So one of the broadest distinctions we can make in types of intelligence is between what's called crystallized and fluid intelligence. So this theory would say that there's only those 2 types. And crystallized intelligence is basically, I almost think of it like semantic memory. Crystallized intelligence is like your memory of facts and knowledge that you've accumulated throughout your lifetime. So people who have really high crystallized intelligence, for example, would be really good at Jeopardy or trivia games, things like that. They would know a lot about history or literature. And so it's crystallized because it's something you've learned, and then it's kind of just sitting there static in your brain like a crystal structure. In comparison to that, or in contrast to that, is fluid intelligence. And fluid intelligence is more like your ability to solve new problems in the moment. So someone who's really high in fluid intelligence, if their laptop stops working, they'll be able to troubleshoot it and put in the right Google searches and figure out what's wrong and fix it, even if they didn't know anything about laptops before that thing happened, right? So it's more like, okay, in the moment, I'm taking the information that's coming at me, and I'm using that information to solve a problem or, to use a skill or something like that. So that's one way of looking at intelligence, is this difference between crystallized versus fluid. All right, so we're talking about types of intelligence. Types of intelligence, first we have crystallized. And crystallized is basically a long-term storage of facts and knowledge. So long-term storage of facts and knowledge. So again, I know that sounds a lot like semantic memory, because it's basically the same thing, it's just a sort of a different way of talking about it. So crystallized, long-term storage of facts and knowledge. And then fluid intelligence is the ability to, adapt and incorporate new information in the moment to solve problems. So fluid is the ability to adapt and incorporate new information in the moment to solve problems. I know we don't talk too much about developmental stuff in this class, but just one little piece of information. Typically, as we get older, especially as you age over like 45 to 50, typically your crystallized intelligence will go up, because basically the longer you live, the more you're absorbing facts and knowledge, the more that like history becomes actually a part of your life that you can remember and understand. But fluid intelligence tends to go down. So as we get older, our brain's like processing speed tends to kind of slow down, and so it's harder to adapt to new things. That's part of the reason we tend to have this stereotype that like older people aren't good with technology. There is some truth to that. Obviously, it's not true for everyone, but part of that might be due to that decrease in fluid intelligence. It just becomes harder to like keep up with all the new things that are coming out and adapt to those as they're changing, especially now that everything changes so rapidly. It's just, it can be very difficult. So, okay, so that's one way of looking at different types of intelligence, is crystallized versus fluid. Another theory that looks at different types of intelligence is called the triarchic theory. So this is just expanding. Instead of only 2 types, now we're at 3 different types of intelligence. And according to triarchic theory, we have what's called analytical intelligence, practical intelligence, and creative intelligence. We'll write those down in just a second. So analytical kind of correlates to fluid. It's basically this ability to like analyze problems and solve them as they're happening. Then there's practical knowledge, which is more kind of like what you might call like street smarts, like your ability to interact with other people and, to get from one place to another and just like, live in society basically and function around others. And then creative would be the more like imaginative, your ability to come up with stories or make music or art, things like that. So that's triarchic theory. I think for triarchic theory, we'll just write down those 3 types.
Is this going to be like under the intelligence things?
Yeah, we're still under types of intelligence. Triarchic. So triarchic theory. Triarchic theory says there is, what did I say, analytical, practical, and creative intelligence. Triarchic theory says that there is analytical, practical, and creative intelligence. And then the final one I want to talk about is called the multiple intelligences theory. And basically, the multiple intelligence theory says that there are actually 8 different kinds of intelligence. So let's do it this way. Let's actually write this down while we're here on notes. Let's just list off all of the 8. So according to multiple, maybe we should capitalize this. According to multiple intelligences theory, there are 8 types of intelligence. And I'm going to put colon. According to multiple intelligences theory, there are 8 types of intelligence, and then we're going to list these off under that. Let me make sure I get them all. And these are not in any particular order. 1 is musical. 2 is what's called body kinesthetic. I think some of these are pretty obvious in the name. I think musical intelligence, you can probably figure out what that is, right? That's your ability to read music, potentially, to play an instrument, to understand musical theory, etc. Body kinesthetic would be like a kind of similar to muscle memory. So it's like an athletic ability. Number 3 is interpersonal. Interpersonal. So interpersonal is your intelligence in dealing with other people. So in having relationships, empathy. That would include probably things like emotional intelligence is something you might have heard of before. That would be part of that, like understanding other people's emotions and how to deal with those and interact with them. So that's interpersonal. Number 4 sounds very similar, but the spelling is slightly different, is intrapersonal. So that's I-N-T-R-A, intrapersonal. And intrapersonal is more like introspective. It's your ability to understand yourself, to introspect, to understand your motivations, to understand your biases, to understand how you think, to know, what do I need to feel fulfilled and happy and successful. So it's more, like self-understanding. Number 5 is verbal intelligence. Again, I think that's probably in the name, but your ability to understand words, grammar, writing, etc., even like communicating with other people. Number 6 is logical, mathematical. So again, I think probably pretty obvious, your ability to understand math, equations, even things like this that we talked about, like probabilities and things. Number 7 is naturalistic. So people who are high in naturalistic intelligence, they have a good understanding of plants and animals and nature. They might be really good at gardening, or they might be really good at, like, you know, training dogs or dealing with animals. And then number 8 is visual spatial. So visual spatial would be, it encompass kind of a few things. So that could be something like visual arts. So someone who's really good at drawing or painting, but also people who are really good at navigating. That would also fall under visual spatial. So again, though, the idea is that according to multiple intelligences, there's at least these 8 different kinds. And part of the idea is that these are all separate, right? So you can have someone who's really high in musical intelligence, but they're low in all the other types or whatever. You could have someone who's high in 4 or 5 of these, but low in some of them because they're independent from each other. They're all like separate types of intelligence. And I would say out of all of the theories, like our understanding of neuroscience and everything probably mostly supports this one. It supports this idea that yes, in fact, there are several different types of intelligence, that they're all separate from each other, that you can be high in one and not necessarily the others, etc.
What's naturalistic intelligence?
Naturalistic is like your understanding of nature, so like plants and animals.
That's cool.
Yeah. All right, so we as humans have a long history of trying to measure intelligence, trying to quantify it and put a number on it and come up with tests that you can like easily administer and, you know, label people as being geniuses or brilliant or whatever. So let's talk a little bit about that history. So I will say that there's a lot of problematic things in our history of measuring intelligence. One of them is that oftentimes that history is focused on maybe 1 or 2 of the types of intelligence that we talked about. So even our modern IQ tests are mostly, they might tap into like fluid versus crystallized, but they're not going to tap into all of those 8 different types of intelligence that I just listed out, right? So, you know, most IQ tests, they have portions that are, you know, aimed at especially fluid intelligence, like if you're solving a problem in the moment. They might have questions that tap into like history and that crystallized stuff. You know, they might get into like verbal and mathematical, but beyond that, they're not measuring the wide range of intelligence that's possible. And yeah, I'll get to my last point of what's problematic as we go. Let's see. So one of the first attempts to measure intelligence was actually in the early 1800s. There was a guy named Sir Galton. I'm pretty sure he was doing it for like military purposes. A lot of the history of IQ measurement comes out of like trying to figure out who we should recruit to be in our military or things like that. In the early 1900s, there was a researcher named Binet who is often credited as kind of like the founder of modern intelligence testing. And Binet was mostly focused on figuring out how to place children in school. So in the early 1900s, at that point, we would not have had like a public education system like we have now. And education would have been fairly expensive. And also, a lot of families would have had much more children than they have now. So they might have had, you know, like 8 or 9 kids or something. So sending all 8 or 9 of your kids to school that's really expensive would have been basically impossible for most families. And so oftentimes, so what Binet did is he developed these tests that parents could give to their kids to try to figure out which kid is most likely to actually be successful in school. So if I give this intelligence test to my 8 kids and, you know, I'm going to take maybe the 2 that score the highest, and I'm going to spend the money to send them to school, and the other 6, I'm going to leave them at home to work on the farm or whatever, because it's not worth it to put resources into these kids if they're not smart enough to actually learn from intelligence, was kind of the logic of Binet's original intelligence testing. And then all of our modern intelligence testing has kind of evolved from that foundation, which is a little bit crazy to me to think about. Because even like standardized tests that you take in school and stuff like that is based a lot on that original foundation. Okay, and then, I don't know, later around, I think World War II is when we got the more modern tests. That says 1958, which would have been quite a bit after World War II, but yeah. So Wechsler is the one that would have developed the most modern one. Some of the important factors of modern IQ tests are the idea that they're standardized and normalized. So standardized means that the test is administered in a very specific way. So you're supposed to get really specific instructions. The format of the test should be the same from person to person. I think a lot of you have if you're running START students at least, you probably have just been doing like state testing. So you're like, this might be very fresh in your memory of those standardized, like filling in little bubble sheets and just the whole format of it is the same. And that format is going to be the same whether you're taking that test here in Longview or if you're somewhere else in Washington or if you're in the Midwest. So it's standard. And then it's also normalized. So normalized means that you apply some statistical analysis to the results. And you basically base the score off of the average based on a large pool of people. Okay. So like I said, there's all kinds of issues with these intelligence tests. One of them, like I was saying, it only measures very narrow type of intelligence and doesn't account for all these other types that are important and valid and interesting and should maybe be taken into account. In addition to that, intelligence tests have a really bad history of perpetuating racism and sexism and other types of very significant biases. A lot of the people who were involved in the early development of IQ tests were actually part of the eugenics movement. You all familiar with the eugenics movement? What that idea is, that's essentially what started the Holocaust. It's basically this idea that people had that some people are genetically superior and therefore we should eradicate anyone who's not of that same genetic class, basically. So a lot of those people are the ones who developed these intelligence tests. And there's quite a bit of evidence that these intelligence tests actually correlate much more strongly with things like your socioeconomic status than they do with predictors of actual success. So people who score high on intelligence tests, essentially all that's showing is that they probably have had lots of opportunities for education in their life, and therefore they're getting good scores on these tests, but that doesn't necessarily mean it's not good at predicting that they will be successful in school or that they'll be successful in particular career paths. And similarly, if someone scores low on an IQ test, really what that's showing you is that they probably came from a poor background and didn't have a lot of opportunity to go to our public school system or to good public schools at least, or definitely not to private schools. That would have been even better. And again, people who score low on IQ tests, they might go on to do extremely well in college or to do really well in certain career paths. So lots of issues with our modern IQ tests. All right, let's write down some of the important points of that. So we're talking about measuring, that's not right, there we go, MEA, measuring intelligence. Let's see, I'm trying to think of the order I want to list these off in. So measuring intelligence, so modern IQ tests are standardized and normalized. So modern IQ tests are standardized and normalized and only measure a narrow perspective of intelligence. So modern IQ tests are standardized and normalized and only measure a narrow perspective of intelligence. We'll put as another point, IQ testing has a history of perpetuating racism. IQ testing has a history of perpetuating racism, and IQ scores are more strongly correlated with, I'm just going to put SES, but SES means socioeconomic status, basically how rich you are, essentially. So IQ testing has a history of perpetuating racism, and IQ scores are more strongly correlated with SES than they are with predictors of real-world success. So IQ testing has a history of perpetuating racism, and IQ scores are more strongly correlated with SES than they are with predictors of real-world success. All right, any questions about biases or intelligence? Okay, why don't I think this is a good place to take a short little break before we get into motivation. So if you want to use the restroom or whatever you need to do.